For Chapter 9, Section 1, we're going to be going over how to graph a quadratic function. And we're going to be talking a lot about the quadratic form throughout this chapter. And this is just one of the ways that we can kind of look at what a quadratic graph function looks like, is by looking at the graph and kind of looking for specific things that tell us something about the equation that we're dealing with. So if you guys remember from last chapter, you started to see the quadratic form, which looks like this, that ax squared plus bx plus c, where a, b, and c, if you remember, those are just numbers, and the x squared is what causes this to be quadratic, because that's going to tell us that there's two solutions to our problem. So when you guys were factoring and doing those different kinds of things last chapter and kind of starting to get an idea of what the quadratic looks like, this really allows us to take it further now and start to see different ways to solve those quadratic equations. And one way is, using graphing, but we'll talk about some other methods throughout this chapter as well. A quadratic form has a shape that's called a parabola. And it's just the shape of that graph. All of these are going to be like U shapes. So they're going to either be opening up or opening down, but they're all going to have kind of this curved V, kind of a U-ish rainbow or arch type shape. A couple of things to know about the parabola. So for your quadratic, is there's something called the axis of symmetry, which means that in the middle of the graph, there's kind of this invisible line that we can think of that cuts through the graph right down the middle so that the left and the right side of the graph are identical to each other. That axis of symmetry is going to go through what we call the vertex, which is kind of the turning point for the graph. So it's kind of in the middle, and right around that point is where the graph decides whether it's going to open up or it's going to open down. If a graph is opening upward, it's going to have a minimum value. So the vertex would be a minimum, where if the graph opens downward, that's going to tell us it has a maximum value. So for example, a minimum graph would open up like this, and the vertex would be at a point like down there. And that is telling us it's going to open up. And so like that vertex point right there would be the lowest point, which is why it's called a minimum. Where if you have a maximum, it flips that graph upside down. And this point at the very top would be your vertex, and that would be the highest point on that graph, which is why we call it a maximum. So just a couple of things to take note of as we start moving into some of these different terms, as we start seeing these different types of parabolas. So this is just kind of a general form of a parabola shape, so kind of what we're going to be seeing throughout this section and a couple other sections when we're dealing with the graphs. But we're going to talk today about how to graph these using a table. And this is especially helpful if you're dealing with a quadratic that doesn't factor as nicely, so it's harder to find the solutions by just doing our factoring methods. So we're going to talk about how to do that with graphing using a table, but I want you to take a look at this graph here that I have. It wants to know what happens to the value of y as you cross the x-axis. So if you're following the graph here, and if you're going kind of up this direction on the graph and you're following it around the top, all of these y values down here are negative, 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 but as soon as they pass this x-axis, they turn to positive, because now we've got positive 1, positive 2, positive 3. And if you keep following the graph, and if you were to go the other direction with it, you're going to start with some positive y values that then eventually turn to negative y values. So anytime that it crosses that x-axis, your sign changes. So we can say that it goes from negative to positive. Or vice versa. It went from a positive value to a negative value. The really important thing to see there is that you're looking for that change of sign, where the y value is going to change from being a positive to a negative, or from a negative to a positive. And we'll see that a lot more when we start looking at our tables, and that's going to be something that you're going to want to be able to identify. So when you're graphing, the steps that you want to follow is to plug in numbers, looking for those sign changes in your y value. So you're going to be putting in numbers for your x, evaluating the function, and you're going to be then looking at your table to figure out what is the y value doing? Where is it changing signs? At what points do we see that happening? And then we're going to talk about how to graph it by going from negative 10 to positive 10. Just a note here, If your value equals 0 when you plug in your x, so if you pick a number to put in for x and you plug it in and you get a 0 to come out, that's going to be a very specific root or a solution to your quadratic equation there. So let's take a look here at an example. And I'm going to talk you guys through also a way to do this using the calculators that I have in my classroom. So if you came in today and you did not get a yellow calculator, I would suggest that you take a second and go grab one real quick, pause the video if we need to have students grab yellow calculators. Alright, so hopefully everyone has a yellow calculator in front of you, or at least a calculator that looks similar to that, because I'm going to show you a really easy way to set up these tables. It's going to save you a lot of time, and it's going to make sure that you're getting the right numbers, and so that there's no error as like you're typing stuff in. Now you could easily pick numbers and put them into your table here. So like my table, I have it starting at -10, and I could include like -9, -8, and keep going. Okay, so I could keep going, and you guys might have space to put more numbers on yours. But what I'm going to do here is, instead of like manually punching these in, so I show you how to do that with the 10 here, where I put -10 in for all those x's, and you'll see that I'm using parentheses to do that because I want to make sure that I teach my calculator how to do the order of operations. You know, calculators are great and they can do a lot of things for us, but they don't understand how to follow order of operations. They don't know to do exponents first and then to do multiplication and division and then addition and subtraction. They're just going to read it left to right and do it how they see it. And so if you don't teach your calculator what you want it to do first, it's going to give you the wrong answers. So you can absolutely do that. If you wanted to type in that sentence exactly how you see it right there to get your y value, there's nothing wrong with doing that. When you do this one with -10, you end up getting 46 to come out. That means that if I had to graph that point, I would be graphing the point -10, 46. Now I could continue to do that for the rest of these points. I could then go to this next one, and I could put in a -9. And that would get me 33. And I could continue to do that trend for the rest of those numbers. But the problem that I see happen a lot here is students forget, or they get lazy and they don't put in the parentheses, they forget to put the squared, they put a plus sign when it should have been a minus sign, they type in something wrong and it gets them the wrong numbers. So those calculators that I have in my classroom have a really cool function that you can use to help make this process a little bit easier. So what you want to do is, on your calculator, I want you guys to find the table button, which should be right next to your clear button on your calculator. So look for the button that says table. Go ahead and click on that once you find it. Now when you open that up, it'll say y equals, and if you have a function already typed in there, like if another student had typed something in, go ahead and clear it out so that you know how to do this next part here. If not, it may say y equals, and underneath it might say enter your function or enter your equation or something like that. And so what you're going to do is you are going to type in this exact sentence up here that I'm highlighting in green. Okay, now your x button, so to get the x to show up, that's on the left hand side of your calculator. Should be kind of by like the numbers 7 or 4. So you're going to type in that, and a little x should come up. And then right above that x button, there should be one that says x squared. So you're going to want to go ahead and press that so that the x squared shows up. And it should pop it up into the exponent spot for you. Then you're going to hit a plus sign, hit your 6, hit that x button again, another plus sign, and another 6 there. So your function should look identical. You should have that x squared plus 6x plus 6. If you're having issues getting this typed in, make sure you ask for help right now. Someone can probably give you some assistance and guidance if you're not finding the buttons or it's not working for you to type it in the way that I'm writing it here. Once you have your function entered, go ahead and hit enter on your calculator. Okay? You're going to get a menu, and it's going to ask you where you want to start. For this one, maybe start at -10, because that's where you started your table at. You could start this wherever you want. You could start at 10, -10, 100, -100, wherever, and it's going to calculate that specific point on the graph and lead you straight there to the table. Now, I would start kind of like where you had your number starting on your table so that you're not having to search for the point that you want to get to. Then underneath the start, it says step. Make sure you keep that on 1. That's just going to make sure that your table is going up by whole numbers. Make sure that the auto function is the one that's kind of highlighted, so it should kind of almost have like a black box, or it's kind of grayed out almost over it. And then go ahead and hit enter a couple times until you get down to the OK, and hit enter one more time, and then your table should show up. Okay, now if you've typed in everything like I've told you to so far, and you've been able to figure this out, you should see at -10 that you're getting 46 in the Y column. At -9, you're getting 33 in the Y column. Okay, if you're not getting those numbers, you need to go back and check your equation that you typed in. Make sure that you're in the right spot on your graph so that your numbers are matching mine here. So what I can do now is I can fill in the rest of this chart, which is going to make my life a lot easier here instead of me having to type these in one at a time. Okay, so I'm going to actually change my graph, my table here a little bit. Because my numbers were so big when I was doing -10 and -9, I'm going to go ahead and skip up to -6 and use some of these to help me out instead. Okay, now like I said, you can start really wherever you want on your table and start with whatever point value that you would want to start with there. I'm going to go ahead and fill in my side of the table, and it should match what you guys are getting on your calculator. Now, if you take a look at these numbers here, so I'm going to erase some of this stuff so I've got some space to write here. If I look here, you know, I was at 46, 33. I skipped a couple here, so now I'm at 6, 1, and then -2. Right there is a sign change. Remember how I said on the previous page that we're looking for where y becomes positive to negative or negative to positive. You're looking for that sign change to happen. So if you keep following your numbers here in your chart, you go from -2 to +1. So there's another sign change. That is where your graph is crossing the x-axis at. So those are going to be telling me where solutions are. So right here where it says root is between, because I don't have any zeros showing up in my chart, I don't have any exact answers. So what I'm going to do is say that one of my answers is between -5 and -4, because that's where 1 went to -2. So the other sign change happens here, because it went from -2 to +1, and that's between -2 and -1. Now you can also maybe notice that there's a bit of a pattern to these numbers here. So like -3 seems to be kind of in the middle, and then if you go up, it goes -2, 1, 6, and if you go the other way, it does the same thing, -2, 1, 6. If you kept following your table on both directions, you should see that the numbers are going to repeat themselves. Again, that's because these quadratics, they're symmetrical. So everything on the left-hand side has something on the right-hand side to match with. So your numbers should be able to match, kind of reflect each other, and have this pattern to them. So this point right here where that -3 is, so this one, that's kind of in the middle, and that's where the numbers kind of start to change on either side of it, that's known as your vertex. So that vertex would be -3, -3. And I'm just grabbing those points from my x, y columns. Remember, x and y, those are all ordered pairs. Okay, now if I wanted to graph this, so you guys should have a spot to graph. And I'm just going to graph these points from -6 to 0, because those are going to be the easiest ones. I'm able to fit those on my graph here. You're not going to want to do like 9 and 10, because those are going to be huge. So there's -6, +6. Here's -5, 1. -4 is at -2. Negative 3 is down at negative 3. Now this is that vertex I said. So at this point, this is that turning point where the graph is going to start to go back up because it's going to make that U shape. So if we go to negative 2, we're down negative 2. Notice how that's like a reflected image of that point over there on the left. And then negative 1, you're going back up to 1. Again, that reflects with that point over there. And 0 is up at 6. So you should have those points so that they're kind of mirror imaging each other there. They're reflecting themselves basically around that vertex. Because really what's happening is through this vertex point here, there's like this imaginary line. I called that the axis of symmetry on the page before. And that line cuts this graph in half. So everything on the left side should match everything on the right side. There should be kind of mirror points there that you can kind of follow and see. Alright, so what I want you guys to do is try this one. Fill out your chart first. If you want to use your yellow calculators like I showed you, I would do that. I'm going to go ahead and give you a little bit of guidance here, and I want you guys to be looking at the points -7 to +1. So I want you to take a couple minutes, either use the yellow calculator to type in your table, your function in your table there, so you can use that and get those answers real quick. If you want to try to type these in one at a time, you can. Just be really careful that you're putting in the right pieces so that you're getting the right answers. When you're ready to see the solution, go ahead and resume the video. All right, so I'm going to go ahead and fill in with what numbers you should have gotten. Again, there should be a little bit of this pattern to these numbers, where if you look, like this is kind of right in the middle. So this is probably where the vertex is, because then your numbers kind of start to repeat on either side of that -10. Now if you look up here, we went from 6 to -1. There's a sign change. So that's where one of your roots is going to be. And the other root is going to be down here, because that's where the other sign change happened, because it went from -1 to +6. Okay, just a couple things to notice, that like right at those points, that should be where they cross the x-axis at, is between those two numbers there. Okay, so let's go ahead and take a look at the graph. I might need to move this over a little bit. I have to zoom out pretty small here on mine to get it to all fit. Okay, I've got one more down here. This is your vertex point. Then those points should start to reflect. And when you graph, you don't want stick straight lines. Mine missed a couple points there, but you get the general idea. It should be that curved V shape. You want to make sure that you have that curved nature to it. They should not be stick straight lines. If you try to draw stick straight lines there, it's not going to pass through those points. It has to be curved in order for it to hit all of those points. All right, let's take a look at this next one together, because the equation that they give us is a little bit different. The main difference here is that they put a 2 in front of that x squared. They didn't just give you an x squared. You handle this the same way that you handled those last couple of problems. If you want to use your yellow calculator to help you fill this one out, that's totally fine. So when I did this one, I did the points -5 to +2. Okay, I typed in all my stuff into my yellow calculator, so exactly how you see it here. So I would have done a 2, the x squared plus 6x minus a 3. And make sure when you have like a minus sign that you're hitting the minus and not the negative key, because there is a difference between those. Okay, and then if I look at this, so if you want to try to type that in real quick and get your table and make sure that your points match mine, this is what I got. 17, 5, -3, -7, -7, -3, 5, 17. Now if we look at this one, the vertex is in between these points here, because there's not a point in the middle of that -7 that I see where it kind of starts to reflect. So it's probably going to be a decimal for my vertex, which is not always the easiest thing to graph. So we'll have to kind of estimate where we think that's going to be. Okay, and then again, where's your roots at? Well, one's going to be right here, because I went from 5 to -3, and then down here I went -3 to +5, so there's another root. Okay, and then I'm going to go ahead and graph this one. Now I probably will not be graphing -5, 17 and 2, 17, because that's going to be way too far off my graph for me. But -4 is up at 5. -3 is at -3. Now, like I said, for these next couple, 4, 5, 6, 7, they're kind of side by side. There's no point in the middle. That means that your vertex is going to be like right here. So you'll just have to kind of estimate. You're going to just dip down beneath those 2 points there. 0 is at -3, and then 1 is at 5. So like I said, when I go to draw this one in, I'm just going to dip below those points and kind of go back up, because my vertex is probably right there somewhere, which if I had put in like a decimal point, I would maybe be able to see where that decimal point is going to be at in order for me to find the exact vertex. But I don't really need you to find the exact vertex right now. I just want you to get used to how these graphs look, what the general shape is of them, so that you have an idea of what the graphs should look like as we move into learning more about how to find the solutions and the exact vertex and those kind of things. The last thing I want to talk to you guys about is how to know what type of solutions you have and how many solutions there should be for your graph. There's 3 main options that we have. We're going to spend most of our time dealing with 2. You probably won't see one of these scenarios until you guys move on to Algebra 2, and we'll talk a little bit more about it then when you guys have had more background knowledge and you have a better understanding of these quadratics. But these 3 pictures all kind of show you the different scenarios that you might run into when you're dealing with quadratics. For this first one, notice how the graph comes down and it hits the x-axis kind of at one spot right there. So this is only going to have one solution. Okay, and that's because the vertex, kind of that turning point, falls on the x-axis. So if you see a graph like that where your vertex is sitting on the x-axis, you're only going to have one solution. This middle one, if you look at the graph, it's way up here above the x-axis. It doesn't actually cross the x-axis at all. That doesn't mean that there aren't solutions. This is the case that we're probably not going to spend a whole lot of time talking about here in Algebra, because you'll spend more time with it in Algebra 2 when you're a little bit more ready for that. This has what we call 2 imaginary solutions. There are answers out there that we can find. They're not going to be considered real numbers. And so like I said, we know that they're there. I want you guys to be aware of the fact that you may see a graph that looks like that when you're graphing these types of quadratics, but you're not going to be dealing a whole lot with actually solving for those types until a couple years from now when you guys are back in Algebra 2. The last situation here is that this graph crosses 2 separate times, which is what we saw a lot of in our examples that we did today in class. And so this has 2 real solutions. It crosses the x-axis at 2 distinct points there that we could find. Whether they're whole numbers or decimals, fractions, whatever, we should be able to figure out exactly where they are by looking at our graph. So when you're looking for your solutions, check where your vertex is, look at the direction that your graph is facing so that you get an idea of which one of these cases are you going to be running into, so that if in the future you start having to find these solutions, you have an idea before you even go looking for them of how many there should be, whether it's 1 or 2, and maybe what they should look like or where they should somewhat be when you're looking at the graph.